All right, glad everyone is here this week. We are on week 4. I can't believe people are still showing up. That's amazing. So glad people are here today. If this is your first time watching or participating, glad you're here. And so we're just as a reminder, we're spending about 12 weeks total, maybe a little bit more in this particular iteration of Failing at Art and thinking about kind of 3 broad level aspects of getting familiar with what R can do. We're kind of this is the last week in our first main section. So we've been focused on data management. And any good methodologist will probably tell you, really any good scientist will tell you, you spend far more time on data management than you actually do analyses. I mean, a good 90% of my time is just slopping around data. So we've been spending 3 weeks kind of looking at tidyverse within R. This is going to be the last week of that. And today we're going to be talking about things like data merging and kind of like data manipulation. We've talked a little bit about data manipulation in terms of sorting data and creating new columns, filtering. But today is more of what happens when you have longitudinal data and you want to make it look multivariate, or if you have multivariate data and you want it to be a little bit more univariate. And so we're going to talk about just some quick things related to data merging, not quick in time, but just high level things, just some introduction into data merging, and then an introduction into kind of some of those data manipulations. And then starting next week, just based on people's feedback, what I think we'll do is just like a 4-week, I don't know if we call it intensive because it ends up being like 4 hours, but just 4 weeks focused on regression. And we'll start with a little bit more of a deeper treatment of multiple regression, in as much as we'll cover a basics about it. But I'm going to assume that most people here have an understanding of assumptions and what regression tells you, thinking about prediction and understanding, but really focused on then exploring what can you do next. And so what does it mean to do moderation? What can you do with simple slopes analyses? And then one of the big time sucks is how do you actually then go from your data into tables? And so I want to show a couple key packages with APA tables and SJplot. Those 2 packages are a huge time saver when it comes to creating tables. And so SJplot is great for kind of conventional OLS, linear regression, logistic regression, multi-level models, cross-classified models. It will simplify your table making process and therefore your life. So we'll talk a little bit about that and APA tables, which will generate descriptive statistics and correlation matrices, and also simplify ANOVA and t-tests, should that be something you're interested in. So we're going to start that next week, and then over those 4 weeks, we're going to go through some basics of, well, advances of multiple regression, and then kind of going into multi-level. One of the things I'm thinking about doing, and I just have to figure out what my calendar allows for, is I just may do some overtime where it may run 1 hour and 15 minutes each time. So that way it's like 5 hours total and people can catch up or stay on. Because I think it's really hard to do some due diligence on multi-level models in 4 hours. But we'll see where we go, and then we'll get to wherever we end up. All right, so if you haven't already, you can go into the week 4 channel, and there's code there. And then there's also some data sets. I think rather than sticking with HSB this week, for the purpose of merging data, I want to be able to just highlight a few different aspects through created data, and show some brief illustrations. So I didn't want to go with very detailed data, but instead have something that's pretty parsimonious. So you won't need to read anything in today. But what you can do is go ahead and load up tidyverse. And we're going to be revisiting some old things in terms of how can we use pipes and how can we use tools within tidyverse to be able to streamline some code, but we're going to really be introducing some new things. So just one quick note, we're going to create a number of different tables, and we're going to do that by using Tribble, which is a part of tidyverse. So Tibbles, as we've talked about, a Tibble, it's a reimagined data frame. So the data frame is something that can appear in your console, and it's just a straight listing of most of the data in your data set. It typically does get truncated at some point, but to get a quick look at data, you can just call a data frame, but a tibble is a little bit more of a reorganized type of data frame. And within tibbles, you actually have tribbles. And so tribbles are a form of a tibble. It's not the Star Trek thing, but what that lets you do is create kind of row by row based tables. And so rather than specifying a matrix to be able to create data, or kind of doing a lot of vector-based language, if you want to create just some fictitious data or something simple to be able to use, you can do X midichlorians are dumb. Look, I agree midichlorians are dumb, but it is canon for better or for worse. We just have to go with it. So we're going to create a tibble using tribble, and we're just going to call it table 1. So we're going to create 2 tables to kind of get our discussions of data merges going. And so this first table is basically, I've talked about Avatar, Last Airbender, and Core a few times. I'm going to just use Star Wars for this first example. And this is just looking at the midichlorian count for, 5 different force-sensitive individuals. And so if you run that line of code, we can do what we've always done, which is call it down here. And you can see that the tribble that we created is now producing a tibble. So it's a 5x2 matrix. We can also just click on the data over here in the environment. It's going to give us the exact same thing. And then if we wanted to, we can also just specifically type view table 1, and we will get the same result. We're also going to create a second tibble. And this is going to be based on those same force-sensitive individuals, how much they like sand. And so Sidious appears to like sand the most. And for anyone who has unfortunately watched episodes 1 through 3, we all know Anakin doesn't like sand. So we're going to go ahead and you can't laugh at your own jokes, but I just do. It just cracks me up. All right, so we now have these 2 different tables. And there's a few different things you can notice about this right away, right? So we've got 5 individuals here, and we have 5 individuals here, but they're not all the same individuals, right? Within table 1, we have Sidious, Revan, Mara, and Anakin, as well as Ahsoka, which Ahsoka is by far the greatest. And then in the second tibble, we have Sidious, Revan, Mara, Anakin, and Rey. So Ahsoka only appears in table 1. Rey only appears in table 2. So this is going to kind of be a little bit of a heuristic in terms of us thinking about how we can merge tables together and the implications of what happens when you have, the same individuals across tables, and what you would look to do when doing different types of merges. So for today, there are 4 primary types of merges we're going to talk about. And again, these are all tidy based. And so tidy uses the join language, which is kind of very SQL oriented. If anyone here programs in SQL or otherwise, there's joins where you're taking 2 different data sets and you are bringing them together. And so we are going to look at examples and talk about a left join, right join, inner join, and full join. And I'm gonna walk us through that in just a minute. But these are the 4 main ones. There's a few other ones I'll show you, but these are the 4 main that you will probably use. And I mean, full disclosure, you're probably most likely to use the full join when you're merging data sets that have common and unique individuals, as well as common and unique variables. And so depending on what you're trying to do, each of these will have a different purpose. I tend to use left joins and full joins the most, because a left join is useful when here is the main data set I want to work with, and I just want to add a little bit more in terms of variables versus, and then there's full joins, which is 2 bigger data sets that have some overlap in each, but there's largely unique characteristics. But regardless of which type of join you might use for merging your data, what's nice about it is that they all follow an approximately same format. So if you remember from the last 2 weeks when we were doing things like the filter, arrange, mutate, select, and what was the last S? I don't remember. Oh, summarize. They all had the similar structure, right? It was you state the command, whether it's filter, arrange, mutate, etc. So you specify the command, you specify the data set that you want to use that command on, you say what you want to do with that data set, and then you win, right? And so it's state what you want to do, type what data set you want to access, say what command you want to use that function for, and then it does it. It's kind of the same thing for joins. All of these joins work the same way. You state the join, which is left, right, inner, full, or the others. And then within that, you specify data set 1, you specify data set 2, and then you say you have a by variable. So if you're going to merge data, you're typically merging data based on some kind of ID variable. So there are times when you are simply concatenating structures, right? You have a data set that has one data that has columns A, B, and C, and a second data set that has columns A, B, and C, and they're the exact same column headers like ID, achievement, and SES. It's just totally different samples, and you want to stack them. You don't need a by variable. You're just trying to stack it, and so you don't necessarily need a by variable in that case. We're talking about here when you're trying to merge cases or variables to a data set, so that way you can add in more information. That's when you need the by variable. So for joins, you kind of type out what join you want. You list out the 2 data sets that you're wanting to use for these examples. You indicate what variable is the common ID between the 2 data sets, and then you run it. So before we get into kind of showing what the joins look like, I just want to kind of unpack what it should look like, because I think it's easier to kind of look at what we expect for the data set result and kind of walk through that. So that way, when we get to the code, it's a little bit easier to understand. All right. So here are the 2 tables that if you've run those files or run those commands, you have these 2 different tables in your data. So we've got table 1 with midichlorians. Table 2 is sand preference. It's the exact same thing we kind of had before. There's the midichlorians, there's the midichlorians, all right? All right, so if we do a left join, what a left join is doing, is that it is taking all of the data in the first data set that you list, right? And so remember, I just kind of said the common theme to these is you list the join, you list the data, and so, or you list what you're joining from, right? So this would be table 1, table 2, and a by variable. So if this was by equals ID. A left join is taking what's on the right-hand side and joining it to what's on the left-hand side. So if we wanted to merge sand preference to a data set that already has midichlorians in it, that's a left join. And what a left join is going to do is it's going to look at all of the data that's in table 1, and it's going to look at who has data for those variables in table 2. And then it's going to merge those data into a new table. And so it's going to bring in all cases and all cases and all columns, but then it's going to treat missing data where appropriate, right? So here we have these 5 individuals who have data on midichlorians. In table 2, 4 of those individuals have the same data. So when we do a left join, it's going to join this data to this data set for those individuals. And then it's also going to bring in Ahsoka. And so Ahsoka has midichlorians, but it doesn't have sand preference. And so it's going to join these data to this data set and produce this table. So what you'll notice here, right, is that it's doing exactly what a left join says to do. It's taking the sand preference data, it's finding the matches based on the ID variables, which are these 4 individuals, and then it's bringing these values into that table. Now, Ahsoka does not have sand preference, but that's okay, because we said do a left join, bring data from table 2 into table 1 for those who are in table 1, right? That's like merge this data set to the right to the data set on the left, keeping the cases that are in table 1. So that's why Ray is not in this data set, because we've said bring in the data where there's a match. And if there's not a match for someone that's already in table 1, just treat it as NA. So that's why we get a table like this. Okay, if you have questions about that, we're going to revisit this in a minute, but you can also populate it in the chat and we'll try to get to that. All right, a right join does it the other way. And so if you do right join table 1, table 2 by ID, and again, this we're going to go into this code in a minute. What you're looking at is join the table that's on the left, which is the first table you lift, join this table to this table. And so it's going to look at all of the cases for the second data set, and then it's going to go to the first data set, and it's going to say, for whom do we have a match? And so we have 5 people here, and so these 5 are going to be in your newly created data set, because it's just like operationally the left join. It's going to merge cases from a second data set into your primary first data set, keeping everyone in your first data set. So Rey is not going to get deleted. So in table 2, Sidious, Revan, Mara, and Anakin all have sand preference data and midichlorian data. And so when we look at matching midichlorian to sand, these 4 values will get merged here. And then Rey only has sand preference data. She does not have midichlorian counts. So when we do a right join, we get a table that will look like this. We'll get all of the sand preference data is listed, and then the midichlorian data will get merged for those who in this table have data that are also here. Rey does not, so she still has her sand preference data, but the midichlorian count comes up as NA. And so you can see that these things operate in approximately the same way. They're just going to retain different individuals based on what your primary data set is. So if you were looking to do analyses that was solely focused on a base sample that had all midichlorian data, and then for those individuals you just want to add in their sand preference data, you could use a left join. Because you're not interested in those who have missing data in midichlorians. If you want those who just have midichlorian data and then add in their sand preference, you can use the left join. If you're kind of doing it the other way, you can keep the same table structure and go, or the programming structure in the code, and say, I want to look at everyone who has sand preference data, and then find those force sensitive individuals who also have midichlorian data. So Rey will be retained because this full data set includes Rey. She's not here, so it's going to show as missing. Ahsoka will not show up in this data set because she doesn't have sand preference data, and that's not what a right join will do. All right, so when we want to start considering individuals who have data on both sides, that's where we can start to get into the inner joins and the full joins, right? So left is take one data and merge it into this other one that has complete. Right join is the opposite of that. An inner join is going to say who is in both that has data on both, and just return that data. Okay, so if we do an inner join and we specify merge table 1 and table 2 together for an inner join, it's going to find the IDs that are common between both tables and have data on both variables. And so what an inner join will return is something like this, right? Sidious, Revan, Mara, and Anakin, they are in both table 1 and 2, and they both have midichlorian data and sand preference data. And so an inner join is looking at taking who is within both tables 1 and 2 and also has data for them. So that's what an inner join will do. And then a full join is kind of where we end up wanting to go for most data, right? We might have 2 different data sets that have some common IDs between them in terms of individuals. There's some unique individuals in both data sets, and there's columns that we want to merge into it. So a full join will say join table 1 and 2 by ID, but then include all individuals and all variables and just give me an NA where the individual doesn't have data. And so it's going to match where appropriate for these 4. Their data is going to come in as complete, just like right here. But then it's also going to append with Ahsoka, who has midichlorian data and no sand preference. And then it will also add Rey, who has sand preference data, but no midichlorian data. And so that tends to be why, for me personally, I use left joins, because I might want, I might have an ID variable that was subset from a larger data set that has complete cases on one, and then I want to merge in some other variables. I'll use the left join, but then a lot of times I'm using the full join because I have an ID variable and I want to both add cases and variables, and I don't care if there's missing data. There are three other quick examples I want to show, and then we're going to get into the code. So one is the semi-join. And so I've already forgotten off the top of my head what the semi-join is. Oh yeah, so what the semi-join does is that if you say semi-join table 1 and table 2, what it's going to do is look who's in table 1, identify who in table 2 is who in table 1 is also in table 2, but then it's just going to return your table 1 data, right? So in this case, it's saying look within table 1, find whoever is in table 1 that's also in table 2, but just return the original table 1 data. So this would only return Sidious, Revan, Mara, and Anakin, okay? And it's only returning midichlorian counts because a semi-join, right? It's a kind of a join. And so all it's doing is saying return those individuals who are in both data sets and have data in both data sets, but only give me my original variables. I don't want the new variables. So SAN preference doesn't come in here. It's essentially a data reduction mechanism for being able to say, return a data set where I don't have this person with some value in another data file. I have never used a semi-join. I don't know if I ever will use a semi-join. An anti-join is the opposite, okay? So a semi-join or semi-join is returning the individuals that are common in both data and have data in both, but it's only returning the variable in your first data file. An anti-join is only returning the individual from your original file that is not in a second file. So it's going to say Sidious, Revan, Mara, and Anakin within the first data set are also in the second data set, but they have data. And so I don't want them. So when you do an anti-join, it's only going to return Ahsoka because she has midichlorian data and not SAN preference. So if you do an anti-join, it's trying to find out individuals who have all the data in your first data set, but do not have any data in the second data set. And it's going to tell you who has that data. All right, so finally, a nest join. What a nest join does is it takes your data from your first data set and it tells you if there is a data match in your second data set, okay? And so if you do a nest join between table 1 and 2, what it's going to do is basically look for all of these people and see if they're in this data set, and it's going to return back the original data set plus a new indicator that says it's going to typically be dichotomous as to is there a match for that individual in table 2, right? So doing a nest join of table 1 and table 2 gives us something that would look like this, where you have all the table 1 IDs in here of Sidious, Revan, Mara, Anakin, and Ahsoka. You get their original midichlorian counts, and then it's going to say, is there a match for them here? So for these 4, we get a 1, which is telling us that they have SAN preference data in table 2. It's not bringing in their actual values. It's just telling you if their data is there, which here the answer is yes. For Ahsoka, it's 0, meaning that she is not located in the second data set. So that's a nest join. All right, that is a quick overview to what the joins will look at like. So that way we can actually jump into the code and kind of see what happens when we run these, right? So if we look at table 1 and 2, and then again, just to kind of show it, we've got ID and midichlorians, we have ID and SAN preference. So if we want to merge individuals from the SAN preference data into the midichlorian data, we can write it just like this. We can say, do a left join of table 2 into table 1 by ID. And sure enough, we get all of the individuals from table 1, Sidious, Revan, Mara, Anakin, and Ahsoka. We get all of their original data, and then we get SAN preference data for each person where they had it. And because Ahsoka didn't have SAN preference data, it comes up as NA. And so with that, we actually don't, we haven't actually changed any of the original tables, right? We haven't specified a new data set. We've just said join it together. So what it's doing is kind of giving you a result of a tibble within the console, but you haven't actually created a new data file. And so we rarely want to just merge data to see a result. We want to use that data for other things. And so in this case, if you want to create a new data set, you can just create table 3 and just say table 3 or whatever you want to call it is equal to this command. We can run it. And then if we click on it, you can see we get the merged data. Okay. A right join is going to be the same thing. If we say right join table 1 to table 2 by ID, it's going to look and try to find if there are individuals with midichlorian. It's going to look in the sand preference data to start, and it's going to say join the midichlorian data to the sand preference data for everyone who is in the sand preference data set. So if we do that, you can see we get Sidious, Revan, Mara, Anakin. Ahsoka does not show up because it's joining midichlorian to sand preference. And Ahsoka is not in sand preference, but Rey is. And so in this data, we get the sand preference score for Rey is there, but she has no midichlorian count. And so it just shows up as NA. And similar to the left join, we can create a table, and we can click on the table, and the data are going to be stored there. What's interesting is that depending on how you arrange your tables in terms of the order, you will get the exact same result. So if I organize instead of right join table 1, 2, I just do it as right join table 2, 1. You're saying join this table to this table, which is the exact same thing as a left join in many ways of saying join this table to this table, right? So if I do right join, I get Sidious, Revan, Mara, Anakin, and Ahsoka. And if I do left join, I get the exact same thing, right? Because I've logically, based on tidy language, I've asked for the exact same thing. I have said, merge this second table into this first table because I'm merging to the right. In this command, I've asked merge table 2 into table 1 because we're merging to the left. So depending on how you structure these things, they will come out the exact same way. All right, let's see. All right, so an inner join. So tables names, yes, it is. It is very good practice to give the tables names. And so for this right now, I'm just kind of running some things numerically. I would always recommend having table names that are heuristically applicable to your field. But I won't get into, oh, should I don't know if I want a rabbit trail. All right, I'm going to rabbit trail for no, I'll save it for maybe later. So I have this rabbit trail that I talk about when it comes to naming things, like how should we name things? But I rabbit trail into latent variables as to whether we should be calling latent variables by like theoretical domains or if we should be numbering them. Because sometimes you run into, for those who are kind of deep into the measurement world, there's this idea of jingle jangle, which is we're calling this latent variable this thing, but is it actually this thing? How have you measured it? What are the indicators? And so you could call something vocabulary, but if you haven't actually measured vocabulary with both what is research informed, evidence-based, and empirically supported, and you're just calling it vocabulary, but it's really syntax or it's decoding skills, you've got jingle jangle. You're calling it this thing, but it's really not that. So sometimes I tend to number my latent variables instead of, and then I explain what's in it, especially if I'm working with data or people that are in a field different than mine, because then I ask them what it should be called. I guess I did the rabbit trail, so never mind. I won't be saving it. All right, anyway, inner join. So here is an inner join if I look at table 1 and 2 by ID, right? That's where I'm looking at who is common between these two tables that has data in both. And so this is an inner join of table 1 and 2 by ID. And so Sidious, Revan, Mara, and Anakin, they have data in both, and it's returning the data in both. And in fact, if I run it the other way, right, it doesn't matter if I do table 1, then 2, or 2, then 1, it comes out identical. The only thing that's different is the ordering of the variables. And that's because if I do table 1 first, midichlorian count is what's in table 1, sand preference is in table 2, and so it's going to order those variables that way. But doing table 2, then 1, it's going to do sand preference first because that is what's in table 2. So you get the exact same data, but the ordering is different. And then if you want to, again, call the table what you would like, so we now have table 6, and that is reflecting the inner join between these two data sets. Here is full join. And so here's a full join of table 1 and 2. So now we actually get all 6 force-sensitive individuals. And so we've got, with missing data on sand preference for Ahsoka and midichlorians for Rey. In the same way, if I run it where table 2 is first, you get the exact same data returned. It's just the columns are ordered. And if you want to kind of go full tidy, right, I could actually select the variables of table 2. Let's say I ran this code, but then I saw the data set were not ordered the way that I want. Oh, I'm going to see if, let's see, it's select. I could actually then just do ID, midichlorian count, and sand. Oh, it didn't like it. It's because I spelled it wrong. Yeah. So if I run that, then I can I could put table 2 first, followed by table 1, and it would. And then if I put the select statement as piping, right? It's saying do a full join and then kind of reorder it by having ID first, midichlorian sand preference. That is equivalent to kind of just running line 60 right there. Those are the exact same things. Why you would want to run it this way, I have no idea. But just wanted to show you just in case you were interested. I'm going to leave that there because I never know what future Yaakov might want for this. And then again, you can create another table from that. You can now, for the first time, see over here, right? We've had 5 variables in each of the tables for the different types of joins. It's not until you do the full join that you actually reflect all the variables with all the individuals. And then quickly for the semi-join, right? That's where it's going to return the individuals from table 1 who have table 2 data, but they're not going to return the actual table 2 data. It's like, I'm going to tease you. Here are the 4 IDs of people who have stuff in table 2, but I'm not going to tell you what it is. That's the semi-join. Anti-join is who in table 1 is not in table 2. That's Ahsoka. And then the nest join is, this is where it's telling you who from table 1 has data in table 2. And you can get this list where we now have the IDs for people from table 1, their midichlorian count. And this is telling you whether they have data in that file. So they have an ID variable, but they don't have sand preference. So that's what that is telling us. All right, so that's a very short and brief intro to joins. But rarely is our data ever simplistic. And so in a lot of cases, I think these different types of joins are going to be very useful, and you can use them in this way for maybe 70% of your cases, or maybe 100%, depending on what you work with. But a lot of times we'll end up having data where we have repeated observations. A lot of times we have multiple identifiers. And so you could have like kids who if it's longitudinal data, they will have the same child ID, but then they're in different classrooms over multiple years. So if you're tracking kids over time and you're looking at their teachers, the kid ID may be the same, but the teacher ID may be different. And so you have to think about doing different types of merges based on the kids, as well as dealing with kind of the teacher IDs. And so joining data is, we won't be able to join data when we have the multiple types of IDs that we just talked about, because this assumes, full join, left join, inner join, right join. This all assumes you have kind of like one row per individual in both data sets. And again, that happens a lot of the time, but it's not inclusive of all of our data. So I want to walk through a few different examples of how do we think about data merging when we have more complex data. And so for this, we're switching gears from one aspect of nerddom to another. We're moving from Star Wars to anime. And so these are using characters from Dragon Ball Z. And we're going to be looking at, is there anyone that's a DBZ fan? I mean, I know not everyone we don't have everyone that's signed up for this on here today. I'm just curious if anyone here is a DBZ fan. If so, solidarity. If not, it's fun, mindless anime with lots of different seasons. And so they have power levels, and it's sometimes 40 minutes where they're all just expositing or powering up, and they don't do anything, but that's part of the fun. And so you have these main characters of Goku, Gohan, Vegeta, and Piccolo. There's lots of different seasons. Sounds like an interesting data. Yeah, I just made up this data set. I just Googled the show and looked at power levels across the seasons. And so I just kind of created this. So you've got Goku, Gohan, Vegeta, and Piccolo. These are different seasons: the Saiyan series, the Saiyan Saga, Namek Saga, Frieza Saga, Cell Saga, and then these are their power levels, right? And so this is just one variable that we're going to have in the data set, so you can go ahead and run that. So we're doing a tribble where we have an ID, a season, and the power level for the Saiyans and the Namekians. So the Saiyans are Goku, Gohan, and Vegeta. Technically, Gohan's a half Saiyan. Vegeta is the Prince of Saiyans. Piccolo's my favorite. If I had my keys, I'd show you I have a little Piccolo on my keychain. Anyway, you can go ahead and run this code, and we're going to read in a data set of DBZ1 that's going to populate here. And then we're also going to look at another data set which has the same characters. You'll see I'm kind of like hashing out some of the data so that way we can have some missing data. But we have the same characters, we have the season, and then we also have an index of how useful Krillin is. So Krillin is another character in the data set, and his job is to always just basically just suck at fighting. He's whining and hiding. He's sometimes useful. So I just invented a metric of Krillin's usefulness. And so we're going to have two data sets, one that has the characters in their power level by season, and then another data set that's the same characters, the same seasons, with an index of how useful Krillin was to that individual. All right, so let's say we have these two data sets and we try to merge them by our ID variable. So if we just tried to do a left join, joining DBZ2, so if we wanted to merge in Krillin's usefulness to a data set that has the individual's power level, and we're wanting to do that based on our primary variable, right? We want to look at how useful Krillin was to Goku, Gohan, Vegeta, and Piccolo. If we try to do just a left join by our ID variable, this is what we're going to get. And so rather than having something where everything is synced up pretty easily, instead what you see is that Goku is not repeated 4 times, or how many times is he repeated in this data set? So he's repeated 4 times in one data and 4 times in another, but instead he's repeated, 16 times? And so for each of his power level is repeated 3 times. And then Krillin's usefulness is being indexed across levels of power. So within the Saiyan, for the Saiyan saga, where Goku's power level was 32,000, it's now looking at Krillin's usefulness relative to Goku's power level in the Saiyan saga. But this doesn't make sense, right? We haven't actually merged our data. We're not getting a sense of Krillin's usefulness to Goku in a particular saga with the correct power level for Goku in a saga. These are things I would never would have thought I would have talked about in my life. My goodness. I'm too big of a nerd. I apologize. All right. So doing a straight join is not going to accomplish what we want, right? Because we're getting 2 different season variables. You've got season X and season Y, and the way that these things repeat is very different. And so what we're trying to get to is a more streamlined data set that is able to pair up based on our 2 IDs, right? We have an individual ID and we have a season ID, and that's not being reflected yet. So we can't do that with, either the left join, the right join, we get the same problem. The inner join, we get the same problem. Season is repeated. We're getting 2 different variables. These things are not synced up. Full join doesn't do it either. What we actually need to do is expand our by variable, right? And so when you have multiple ID variables and you're saying merge in these other variables, but account for the fact that there are different ID variables that repeat on different intervals, that's where you can do this, right? So I could do a left join where I can merge Krillin's usefulness into a data set that has Goku's power level or their power level, and then I just specify the 2 ID variables, right? ID variable is first, and then season is second. And so if I do a left join that way, now I get a data set where we have 4 rows per individual. We have the season that's repeated within an individual. We have the correct power level for each individual, and we have Krillin's usefulness for each individual person, okay? So whenever you're merging data and you have things where individuals are repeated and you might have multiple identifiers, you can just list those identifiers by kind of creating this concatenated vector that identifies those identifiers. And then it's going to merge all the other variables in there, considering first ID and then season. So that's a way to be able to handle a little bit of more complex nesting. Okay. You know, in your spare time, I encourage you to just like take some of these things. The expectation, right, is that you're taking some of these data, doing analyses on your own with your own, and kind of screwing up on your side. So what I want to get to now is the idea of data shaping. And so that is, once you've gotten to a point, it actually could be pre-analysis and pre-data merging. It can be post-merging pre-analysis, where we are almost always interested in shaping data. So using the data that we just read in, the Dragon Ball Z, DBZ 1 and 2, it was both purposeful for looking at multiple identifiers, but also data shaping. So there are 4 things that I want to walk us through in our remaining time. And that is spreading your data, gathering data, separating, and uniting. And so spreading is when you are going from long data, or univariate, to wide data, multivariate. Oh, I see Florina's on. Florina, congratulations. You just got, it was like Researcher of the Year at Texas A&M University in your department. Is that right? I saw that on Twitter, so great work. That's my ADHD, but for a very positive thing. So Florina is an amazing scientist. She won a big award at her university. Get to know her work. She is brilliant. Okay, so spreading is when you have long data and you want it to go wide. Gathering is the other way, right? Like when you have lots of variables, let's say you have 10 time points per individual, and you're trying to do growth curve analyses. And most data systems require you to have univariate data. And so if you want to be able to kind of go from wide to long, you need to gather your data. You need to take those 10 measurement points, you need to rotate it. Separating is when you want to split a variable into 2 different variables. And then uniting is taking 2 different variables and then concatenating them into one variable, okay? And then just to kind of show, so if we take that original data set we talked about before, I think it was DBZ2. This was like Krillin's usefulness. Like Goku has 3 rows, Gohan has 3 rows, Vegeta and Piccolo. This is a long data set, right? Long is usually reflective of the fact of the number of times the main ID variable is kind of exists in the data. And so a long file is usually a repeated ID for the individual. It's also univariate. And so we have Krillin's usefulness is expressed one time. We don't have a Krillin's usefulness variable for the Saiyan saga, the Namek saga, and the Cell saga, right? That would be a multivariate. That would be a wide file. So a univariate file is where you have one variable to describe or characterizes the data, even though it's repeated across individuals. And then a multivariate data is something that's more like this. Okay, this is actually a flipped version of this data set. So if I wanted to be able to express this data by multiple variables rather than by one, that's where you spread the data. So in this case, I am spreading Krillin's usefulness over levels of season. And so Cell, Frieza, Namek, and Saiyan, those are now variables. They're no longer, and it's no longer an ID variable, it's now a variable. And these cell values correspond to what was in here. So in SPSS language, this would be a cases to vars. If we wanted to take this data and go from wide to long, that would be vars to cases, where we're gathering these data. So that way we can go to univariate. So that's just a little bit. Oh, no, univariate is long, right? So it is uni, right? Uni one variate variable. So we have one variable. So even if the data is kind of multivariate in nature, we have multiple measures of Krillin's usefulness for Goku, we can express it univariately. It is long. But if the data is truly multivariate and you want to specify it multivariately, right? Multivariate, multiple variables, then we can spread this data so we have multiple variables that each represent Krillin's usefulness. So univariate long, multivariate wide. Let's jump into the code. Yeah, we're actually going to be, that's a great point, Andreas. I'm going to be actually showing pivot longer and pivot wider towards the end of this. So thank you for bringing that up. That's a good teeing things up in many ways. Okay, so the form for spread is, it's spread. You need to identify the data, and then you identify a key and you identify a value. Okay, that's like the formal language for data spreading. It's spread, you identify the data set, you select a key, and then you select the value. What that really means is that it's spread, identify your data set here, then you're identifying the column that you want to spread, right? And so in this case, when we were talking about going from long to wide, when we're spreading, we would want to be spreading season, because we want season to be represented multivariately. And so the column to spread is what you want to represent now as variables. And then the value is what you want, what data you want to fill those cells. So here's a little bit more lay language that I have. So you're wanting to spread an existing variable that has multiple categories within an ID into a new variable where those categories are now variables, right? So it's spreading something like season, because season has multiple categories that's within an ID like Goku. And we want to create a new variable where those categories are now variables. IDs are no longer repeated, they're in a single row. So we're trying to spread the data so that way Goku is in one row. And then we're using the values from the original entries into the cells of the new variables. All right, so it's going to make a little more sense as we walk through this. So just as a reminder, so here's what we're going to start with. We're going to start with DBZ1 and we're going to spread it. And so if we want to be able to have a multivariate data set, because it's univariate right now, and we want a single row for each character, we're going to say spread, just like up here, spread the data set DBZ1. And we want to spread according to season. So we want seasons to not be represented as categories that vary over individuals. Instead, we want these categories to now be variables. And we want power level to actually be the values that go into those cells. I'm going to run that first before I show the second one, just to get, oh wait, it's right there. So if I do that, I'm going to make this a little bit bigger. Let's see. You can see that each person now has their own row, and the variables of Saiyan, Saga, Namek, Frieza, and Cell, those are now variables, and now the cells have the values. Okay, so for Goku, we have Saiyan is 32,000, which corresponds to here. The Namek Saga at 65, which is right here. The Namek Saga, or the Frieza Saga is, what, 2 million? And then for the Cell Saga, it's really high. So what's hard about this is we can't automatically see kind of the correspondence. And so what I'm doing here is what I did earlier, right? I'm piping to say, spread the data and then kind of select the variables in this way. So I'm just kind of arranging it a little bit differently. So what's going to come out is something that looks a little bit more like what we had before. So let me see if I can do this just to make it a little more salient. All right, so it's sorting the ID alphabetically. So if we want to look at Goku, we can look at this row. So 32, 65, 2 million, and what, 564, is that million, billion, 546 billion, right? So it's, when we rearrange them, we now get the right ordering of the saga, and we get the right power levels there. And so this is spreading the data, so that way we can use it for multivariate purposes. And then if you want to, so then if you want to then actually create the data set, this is where I'm creating DBZ1 multi. So this is where I'm just creating that multivariate version of DBZ1. I'm spreading the data. I'm then selecting the variables in the way that I want them to appear. And so now I have a new data set where the univariate data has now been flipped to multivariate. I'm going to skip the second example right now. This is Krillin's usefulness. I'm just going to run it because I think I need it for something else. And so you can do the same thing. create the data set. You can select it in the way that you want if you want to. We might as well view it. You can see there's a lot of missing data and a lot of negative numbers because Krillin's not useful. At least in Dragon Ball Z. In Dragon Ball, maybe he was useful, but they were also kids. So, all right. Anyway, all right. So spreading is taking your long data, making it go wide, going from univariate to multivariate. Gather is the other, right? And it kind of makes sense. You're gathering it. You're bringing it in. So gather follows a very similar format where it's gather the data. You include a key, and then you specify a value. And so a little bit more on that is you specify the data set. You specify the new column that you want from the variable names. You specify a new column that you want that has the variable values, and then you specify the variables themselves. All right. So doing gathering is a little more complicated because if you have a multivariate data set, there are two things you have to do, right? So if you're wanting to repeat each of these characters multiple times, you can see there's two new variables we have to create. We have to be able to index the sagas by a new variable, right? So our original data set had a season variable that had the 4 sagas and the power level where the numbers are there. But now we have 4 different variables, and we need to both collect these variables. We need to gather them under a new variable name, but then we also have to do the same thing with these values, right? If we're going to create a new variable that has the sagas listed, we need another variable that has the values listed. So that's why gather is a little bit more complex. And so in terms of lay language, we could say when we're doing gather, we're going to gather the existing variable names that you list, which would be these ones right here. We're going to gather those into a new variable that indexes those original variable names. And so we're gathering these, and then we're using them as indexes under a new variable where they are now categories rather than variables. So we're doing that, and then we're gathering the values from those original variable names into a second new variable, right? So to say that again is we're gathering these existing variable names into a new variable, and then we're going to be gathering these values into another new variable, okay? So to do that, just to show as an example, here's the multivariate data set. And so if I now want a univariate data set, I'm going to say gather the variables from this data set, and I want to gather the primary variables into a variable called season, and then I want to gather the values into a variable called power. And the variables that I want to gather are the Saiyan saga values through, right? That's the colon is Saiyan through cell. So these are ordered this way. So instead of listing them out, I can just say Saiyan saga through cell saga. I could also do variable numbers 2 to 5 in this data set. So this is again saying create a long or univariate file from DBZ1, the multivariate data set, and create a variable called season from these variable names that I list here, and also create a variable called power that's a function of the cells. And so if we run that, you can see we now have moved from the wider data set to a longer data set. And if I run it this way as well, the DBZ1 multi through just the variable names, we get the exact same thing. All right, so now we do have to be careful on how we list the variable names. And I think I show why in a minute, but we'll get there. All right, so example 2. Oh, this is just example 2, so we don't need to, I think I'm going to skip that for now for time purposes. So what I'm doing is just formally creating saving univariate data versions of DBZ1 multi, which was power level, and DBZ2 multi, which was Krillin's usefulness. And so I basically recreated our original files in a new way where we have season and power for DBZ1 and then season and Krillin, kind of acknowledging, is he kind of useful? Oh yeah, so what's important to note is that within gather, kind of getting rid of missing data, you don't get rid of missing data by default. And so if I was to gather these data from DBZ1 from the second data set, the Krillin data set, right, there's a lot of missing data. And so it's kept by default. So if I kind of arrange this by ID, you can see that the NAs are there, but I can kind of delete missing data using NARM equals true. And now you can see it's reduced down. There's no missing data. All right, we've got just a few minutes left. Let me see what's going to be. All right, so here's what I'm going to do. I would say look at the separate and unite on your own time. That's where you're splitting out variables into separate, into separate variables. I will do it very quickly to show you're just splitting a current variable into separate. So if we take DBZ1 uni, if I wanted to split out season, right, there's an underscore here from Saiyan and Saga. Let's say for whatever reason, I don't want Saga. I just want a variable that says Saiyan, Namek, Frieza, etc. What I can do is this right here, which is separate DBZ1 uni, separate out the variable season, separate it into two variables called season name and saga, and then make the separation based on the underscore. So this only works if you have kind of a common character that you can then split it out. So because all of these have an underscore, then I'm saying split out the season variable into two variables called season name and saga, and split it according to the underscore. So that way the first part goes into season name, the second part goes into saga. And so now you can see there is season name, which is just Saiyan, saga, which is just saga. And then unite is the same thing. I can unite those things. But what I want to make sure to get to is down here, which is pivot wider and pivot longer. And so this is where you need to be able to kind of spread based on multiple variables and gather based on multiple variables. And let me make sure do I have full DBZ? No, I need to run that 1 second. There we go. So full DBZ. So this is where I'm doing a full join, right? I showed a left join for where we had multiple ID variables. Here I'm doing a full join where I'm bringing everything together, all cases together based on ID and the season. And so here's that kind of full data set. All right, so now if I want to, there's full DBZ. All right, so pivot wider is where you're trying to kind of spread your data based on having multiple variables to spread, right? So the example before was we had ID, season, and power level, or ID, season, and Krillin's usefulness. Now, what happens if we want to spread across season, but as a function of power level and Krillin's usefulness? And so you can't actually do that based on using spread and gather. You actually have to use pivot wider and pivot longer. And so it's actually pretty simple. What we do here is a pivot wider, you specify the data name, and then you say that the names are going to come from season, just like we did before where the key was the seasons. It's like, what do you want to make as a variable name? And so the variable name is going to come from season. We want something that is we want a multivariate data set that reflects the power level across each of these 4 sagas and Krillin's usefulness across each of the 4 sagas. Do you have any documentation on your file? Yeah, I can send more information on that, Amy. Happy to. And so this is again, this is similar to spreading the data if you're wanting to go from univariate to multivariate, where you're identifying the variable that you want to create multiple variables from. So again, season has these 4 different levels. I want this to be represented where Goku has 1 row, not 4. And so that means I actually need to create 8 variables, right? Goku's power level has 4 levels for these 4 seasons. And then Goku also has an indicator 4 times of Krillin's usefulness. So I need to go from 4 variables to 8 variables. And we can do that through the pivot wider of specifying the data set, identifying the indicator, which again is season, that has the 4 different levels that we want to make new variables from. And then the values for each of those new variables come from power level and Krillin's usefulness, right? So it's essentially pairing power level with season and Krillin's usefulness with season. So now we get something like this, okay? And I'm going to actually kind of create the data set so I can open it. So I'm creating a new data set that's a multivariate version of DBZ1. And so you can see we've now gone wider with those data, where the first part of the entry is the original variable, right? It's power level for Goku, and then it's the saga. So it's power level underscore saga. So his power level for the Saiyan saga, the Namek saga, the Frieza saga, and the Cell saga. And now we have 4 other variables for Krillin's usefulness in each of those sagas. So we now have 8 variables that represent, before they were 2, right? We just had power level and Krillin's usefulness, but now we're spreading it out. So that way power level and usefulness is tied to each of the sagas, and each individual is reflected by 1 row. I know we're a little past time, so if you need to go, feel free to. I'm going to spend a few more minutes talking about the pivot longer, because that one's a little bit more complex. So just check out the video. And for those who have to jump off, we will see you next week. Thank you for coming. All right, so that's pivoting wider. So if, again, you have multiple variables, which is often the case for us, right? We rarely have 2 different kind of ID variables and then 1 variable we're interested in. We're usually trying to flip multiple variables. And so the way, again, we do that is by identifying the primary indicator that we want to represent as variables, and then the different variables that we want reflective of the category. So if this was time, so if we were looking at 4 time points and we were looking at Goku's reading skills and language skills, this might be kindergarten, 1st, 2nd, and 3rd, and then this is reading and language. And so we're essentially saying, give me a multivariate data set that is based on time, that has his reading and language scores, and give me 8 different variables that reflects that. So that's what the pivot wider is going to do. All right, pivot longer is a bit messier, and so I want to make sure to take enough time to really explain this. I'm probably going to botch it, so I need to explain it again. And you'll see there's like longer explanations. It's because for me, you know, like Winnie the Pooh will kind of say a lot like, I'm a bear of very little brain. And so I like to use that a lot to kind of characterize where I get into stumbling blocks of comprehension. This took me a little bit. All right, so pivot longer tends to follow this kind of structure. First, it's like negative variable. I'll explain that in a second, okay? So it's like negative variable. Then you have an indicator of the names that you actually want to separate on. Then you indicate the names that you're separating them to, and then whether you want to drop the values or not. So that's the formal structure, but it is a horrible way to explain it, okay? A better way to kind of say it is that you want to start with the variables you don't want to gather. A lot of times that's your ID variable, right? So here, let me actually bring up the multi. So if we're trying to pivot this data longer, we actually want to make the power level variables its own variable, right? And so like what we had before, we want power level to be a variable. We want Krillin's usefulness to be a variable. So we want to be able to kind of gather those data together, but we don't want to gather anything related to the ID variable because the ID variable is not a variable. We don't want to gather ID. So you start by first listing the variables you don't want to gather. Then what you want to do is specify what is separating the different levels of the variable. And so in this case, it's an underscore, okay? And so the underscore is what separates what's being measured from the category, right? And so what precedes the underscore is the measured variable, power level, and Krillin's usefulness. And so that's what you put there under the names separate. It's an underscore. Then you specify the new column name. In this case, we need to specify multiple column names because we have power level and Krillin's usefulness. So one of the ways we do this, what I kind of want to show here, is that a lot of functions that you'll see is something that looks like this. It's pivot longer. You have a negative ID. You have the separating feature, which in this case is the underscore. And then you're saying, where do you want to send that information to? And you'll sometimes see this period value followed by another measured variable, right? And it took me a while to really understand what the relation is between sending information from the names that you're separating on to these other variables, right? So what it's saying, pivot longer, don't include ID in the way that you're gathering the data. But first, look at your variable names and separate the variable names according to what's before and after the underscore. And so we have power level that's before, and we have a saga that's after, or we have Krillin's usefulness before and saga after. And so dot value is a way to be able to assign different aspects of what's happening in the variables with what's happening in the cells. All right. And so I'm going to stretch this out so you can see it. And I'm going to walk through this. We're going to kind of walk through this together. All right. When you have something that is in a structure of dot value, comma variable, it means that what comes before the separator is going into a new variable name, and what is listed after the separator are the values that go into a newly created variable. Okay, I'm going to explain what that means in just a minute. If instead you have something that looks like, var comma dot value, it means that what comes after the separator goes into a new variable name, and what's before the separator are values of that go into the new created variables. So when we look at this data set, what we're saying is we want to pivot longer so that power level and Krillin are variables and that the sagas are indexed by a new variable, right? So we have power level underscore Saiyan saga and Krillin's usefulness underscore Saiyan saga. That's what currently exists in this data set. If we include in our names to the dot value comma var, what's going to happen is data are going to be gathered based on what comes before the first underscore. Okay, so it's going to look to say we have 8 different variables. How do we cluster them together into variables? If you have dot value comma var, it's going to say look at what comes before the first variable. In this, the first underscore, which in this case is power level or it's Krillin, and then we're going to index that, and then it's going to be indexed or it's going to be grouped by what comes after it. Okay, so we're going to create a new variable called power level and Krillin, and then we're going to have a new variable that shows the grouping of that. So let me show you what that looks like in actuality. So when we have value, dot value comma season, and we're pivoting longer for everything except for ID, so it's going to take these 8 different variables and it's going to try to create these into something smaller that is longer. We're saying take everything that is before the underscore. When we say value, take everything that's before the underscore and create those as new variables, which is power level and Krillin's usefulness. So create 2 new variables called power level and Krillin's usefulness, and then populate those 2 variables with values according to season. And season is going to be defined by what happens after the first underscore, which is the Saiyan, Namek, Frieza, and Cell. Okay, so if we run that, we can see that what this has done is said, separate the variable names according to the first underscore. Whatever appears before that first underscore, that is what we're going to use to create new variables. So for these 8 variables, we had 2 different types of indicators. We had power level and Krillin's usefulness. So it's creating power level and Krillin useful as the variable names. And then it's saying create what comes after the first underscore as season. So what comes after the first underscore is Saiyan, Namek, Frieza, and Cell. And that's what's getting populated in this season variable. Okay. I put down here, it took me kind of 2 hours to get this. So it's okay if this is super confusing. What we'll probably end up doing once I kind of cut this video is if people want to ask questions, you can populate those here. But I want to show you what happens if we flip around the logic, right? If what tidyverse is doing, if it looks at what comes before the underscore and creates that as a new variable and then indexes it according to what's after it, then if we flip these 2 things, we're going to get kind of a wonky data set, right? And so instead of us getting a data set where power level and Krillin's usefulness are the columns, they're now an ID variable because we've said season is first and value is second. So it's looking at what is before the first underscore, and then it's looking, or sorry, what's after the first underscore, and then it's assigning that to be the new variable. So after the first underscore, when you do var.value, it's treating season as the measured variable, and then it's subsetting Goku's power level and Krillin's usefulness to Goku in the season, right? And so depending on how you organize your grouping, your gathering of data is going to look very different. So what I tend to do is use something like this, because while this could be interesting, it's still not giving me exactly what I need. So instead, indexing it by using the value first and the season second, ensuring that my variable names are where I have the variable name by the categorical variable. So having power level first, Krillin's usefulness first, and then what's after the underscore is kind of the category. This will allow you to be able to do more of that kind of multiple variable gathering that using gather won't do. So we are pretty much at time. I know that last piece is a little bit wonky. And so what I would do is maybe look through this example a little bit more, try the examples out for yourself. We can spend a little bit more time revisiting this, where we can kind of go through what it means to have dot value first versus second tied to your separator. So we'll revisit this a little bit more next week. But then we will jump right into kind of regression, multi-level modeling. Yeah, maybe I see someone said Avatar examples. Maybe Avatar, might go with maybe Final Fantasy for next week. Final Fantasy 7, we'll see. But thank you all for joining. I hope this was helpful, and I'll see you next week. Thanks.